Good day and welcome to Big Bad Tech. I'm your instructor Jim Pytel, and today's topic of discussion is the voltmeter. Our objective today is to take a quick look at the voltmeter function of the digital multimeter. We'll use the function, leads, range, and placement checklist for voltmeters and discuss voltage polarity. If you'll recall, during the ohm meter lecture, available at the Big Bad Tech channel, I introduced the ohm meter function of the DMM. And if you haven't checked this lecture out, I'd recommend doing so now because we'll be following a similar format and use the same hardware to discuss the voltmeter aspect of the DMM. The DMM is again a single meter that has multiple, hence the term multi-mode settings. DMMs can be used to measure both the DC and AC voltage, DC and AC current, resistance, capacitance, forward bias voltage of a diode, frequency, and more. Today we're only going to briefly look at the voltmeter function of a DMM, where a voltmeter is a device used to measure the voltage between its two terminals in units of volts. This discussion of voltmeters will be brief for two reasons. One, you'll be happy to know that using a voltmeter is not that hard. And two, a discussion of voltmeters would be purposeless if we didn't discuss voltage rises or voltage drops inside circuits. The topic of voltmeters, power supplies, and electrical circuits are tightly intertwined, and it's hard to separate one without going into detail about the other. That being said, I'm ripping them apart and sending them to opposite corners of the lab where we can get a good look at one without being entangled with the other. This is the briefest of brief summaries of voltmeters and serves only as a springboard for later discussions. Stay tuned for more lab practices lectures in this playlist, which will include more detailed discussions about voltmeters. Again, I have no idea which DMM you're going to be using during the course of your employment, school, independent study, or hobby work. It is for this reason that I'll employ 3 different DMMs in voltmeter mode during the course of this lecture. They are the Fluke 87, the BK Precision 2831D, and the Hewlett-Packard 34401A. This is in no way meant to be neither an exhaustive review of these meters nor an endorsement of these particular brands or models. I only wish to present the voltmeter function on different meters so you can see how the function, leads, range, and placement checklist is employed and interpret the manner in which results are displayed. Given the DMM is the device which you will most frequently employ, it is of paramount importance you become intimately familiar with your DMM and learn its ins and outs, ranges and limitations, and peculiarities. Spend some time with it and get to know your DMM. By all means, RTFM. Read the fine manual. If we recall correctly, 2 major characters in the Basic Electrical Quantities lecture, available at the Big Bad Tech channel, were voltage and current. Voltage and current don't mean the same thing, and they are not measured in the same manner. In my experience, individuals struggle to understand the concept of voltage, a differential between 2 points, yet in practice find it very easy to measure using a voltmeter. The opposite can be said about current. The concept of current, physical movement of a quantity of moving electrons past a point in a given amount of time, is very easy to understand, yet in practice very difficult to measure. You can't have it all. The concept of voltage is hard to understand, but very easy to measure. The concept of current is easy to understand, but hard to measure. Since we're dealing with voltmeters this lecture, let's refresh our concept of voltage, where voltage is a differential observed between 2 points. Voltage is measured across something, where one point is measured with reference to another. The phrase "with reference to" means here is the point I am comparing all other points to. The common lead on a voltmeter is the reference lead, and is typically the black hole. You can plug a red lead into a black hole, and you can wear a hat on your foot, but that's not its intended purpose. In technical terms, voltage is the energy in joules per coulomb, a unit of charge. I know what a joule is. A joule is a newton of force applied for a distance of 1 meter. And I know what a coulomb is. It's a lot of electrons. But this is still kind of hard for me to understand when I try to visualize it. It helps me, and it might help you too, to think of voltage just as a measurement of differential in charge concentration, and leave it at that. If there is an equal number of positive and negative charges between the 2 points, there's no voltage differential. And if you put a conductive path between these 2 points, the positive and negative charges would be like, I don't want to move. There's no incentive to do so because everything's the same. It's kind of like moving from Detroit to Pittsburgh. I mean, why would you want to? If, however, there's an excess of negative charges in one spot and an absence in another, a differential between these 2 points exists. and the magnitude of this difference is measurable in units of volts. The more difference, the more voltage. A difference between 2 points is measurable despite there being no path between them. If a conductive path, however, is placed in between these 2 points of interest, the charges are now like, oh yeah, road trip. Kind of like the mass exodus of humanity from Detroit and Pittsburgh to all other points that are not Detroit and Pittsburgh. The charge's level of willingness to embark upon this adventure is directly proportional to the voltage differential between the 2 points and inversely proportional to the opposition or resistance of the obstacles they encounter along this path. The amount of moving charges is measurable as current, which is the effective voltage. It should be obvious I'm referring to Ohm's law, an incredibly important cause, effect, and opposition relationship essential to your understanding of basic electrical phenomenon. Either way, this differential in units of volts is a 2-point measurement and must necessarily be across something. The 2 terminals of a voltmeter simply touch the points of interest, and the voltmeter displays a value in volts. This could be for the voltage drop across a passive element, or the voltage rise induced by an active source. The takeaway point from this whole excursion is that voltage measurements are across something, and would not make sense if both leads were placed at the same point. If the voltmeter is supposed to be determining the difference between the high lead and the reference, and the high lead and reference are at the same spot, there is no difference between them because it's the same spot. Voltage is across. Voltage is a 2-point measurement. Here is a DC power supply with 3 outputs, 2 of which are adjustable and 1 of which is fixed at 5 volts between these 2 terminals. All we'll do today is quickly use the function, leads, range, and placement checklist for 3 different DMMs in voltmeter mode to check the voltage of this fixed 5-volt DC output. The checklist has 4 steps: function, leads, range, and placement. Follow them in order and you'll get it right every single time. Skip a step, do a step wrong, or do a step out of order and you'll get it wrong every single time. Function. First up is our Fluke 87. We'll place it in DC voltmeter mode by turning the mode selector to the V with a straight line over it. Don't get tricked into settling for the modes on either side of DC voltage. The V with a squiggly line is AC voltage, and the millivolt with a straight line over it is for small-scale DC voltage measurements. These aren't the modes you're looking for. You want the DC voltmeter function. Leads. Now that the DC voltmeter function is set, figure out where the leads go. The black lead goes into the black common hole. This is the lead that will be used as our reference. Red lead into the red hole, indicated with a V, the shorthand for units of volts over it. Range. The Fluke 87 is auto-ranging, so we don't need to worry about manually ranging it. Isn't that convenient? You can force it out of auto-range mode if you want to, but we'll keep it as is. Placement. Now all I've got to do is place our voltmeter leads across our terminals of interest. If I want to see the voltage differential exhibited by the red terminal with reference to the black, I place my black lead on the black terminal and my red lead on the red terminal. The voltmeter indicates that the red terminal of the power supply is 5 volts higher than my reference. What if I was to swap my reference position on the voltmeter though? If I place the reference lead on the red terminal of our DC power supply and the high lead of my voltmeter on the black terminal of our power supply, the voltmeter now indicates the black terminal of the power supply is simply 5 volts less than what I'm using as a reference by putting a negative sign in front of the reading. The magnitude, 5 volts, is the same. It's just that we're viewing the difference from a different frame of reference. This positive versus negative value of voltage is known as polarity. There's a little dude in your DMM. Seriously, there is. And he's the guy that determines polarity. This little guy lives at the reference position and has a tape measure that he rolls out and notes the reading of on your DMM screen. If he's at a point where something is higher than him, he writes a plus number. If he's at a point where something is lower than him, he writes a negative number. The reference lead of the voltmeter is the point from which all other points are measured and compared to. It's all relative, just like the dating scene in Clackamas County. You guys do realize I'm joking about the little guy in the DMM, don't you? Don't take your DMM apart thinking you can find this guy or ever tell your lab instructor or employer about this method of instruction. It's simply an entertaining and memorable means of getting you to understand reference and polarity. Next up is the BK Precision 2831D used as a voltmeter. Function. We'll place it into DC voltmeter mode by pressing the voltmeter function, again symbolized by a V with a straight line over it. Leads. Now that the DC voltmeter function is set up, figure out where the leads go. Black lead into the black common hole. This is the lead that will be used as our reference. Red lead into the red hole, indicated with a V, the shorthand unit for volts over it. Range. The BK Precision 2831D is a manually ranged meter. So prior to measuring something, we need to tell our meter in which range we'll anticipate results. The meter has the following ranges: 2, 20, 200, and 2000. But if we read the fine print, we'll realize the 2000 range is actually subdivided into 1200 volts DC and 750 volts AC maximums. If we expect a reading of 5 volts, what is the most appropriate range? 2, 20, 200, or in the case of DC, 1200. Obviously, the answer is 20 volts, because the 2 volt range won't measure it, and 200 and 1200 volts won't measure it accurately. You might have picked up on it by now that I'm unusually firm about using the function, leads, range, and placement checklist every time we use a meter. It's at this time I need to remind you of how serious I am. This checklist might save your life. If you were to accidentally have this meter placed in the 2 volt range and measure something close to 1000 volts, it could not measure it because it's out of the meter's range. If you were to accidentally interpret this over-range reading as an indication of 0 volts, you could expose yourself to potentially deadly voltage. Use the function, leads, range, and placement checklist correctly every single time. Use the checklist, think about it, really think about it. Take your time and think before you act. One further consideration of range before we move on. What if we didn't know what to expect for a voltage reading other than it was below 1200 volts? My advice is to move in cautiously and work your way towards the most appropriate range. Send in an armored infantry fighting vehicle by operating in the 1200 volt range. If the opposition easily folds, dismount your riflemen in the 200 volt range. If the opposition easily folds, have your squad fix bayonets in the 20 volt range. If the opposition folds again, let your squad go hand to hand in the 2 volt range. What you're doing is you're progressively working yourself into the most accurate range and never allowing the voltmeter to be exposed to an out-of-range condition. If you encounter stiff resistance early, you've got the firepower on hand to back your position up. Placement. Now that we're in the DC voltmeter function, our leads are in the correct place, we're in the right range, all we've got to do is place the voltmeter leads across our terminals of interest. In this case, we're again observing close to our expected value of 5 volts. And if I swap the leads, we could expect to observe the same magnitude but of opposite polarity. Finally, we'll take a look at the HP 3441 in voltmeter mode. Function. We'll place it in the DC voltmeter mode by pressing the function button identified by a DC V. Notice this meter spells it out for you and doesn't use a V with a straight line over it. Leads. Now that it's in voltmeter mode, figure out where the leads go. This meter doesn't use black to identify the common hole for reasons I simply do not understand. The common is the center hole on the right-hand side of the 3. This is the lead that will be used as our reference. The red lead into the red hole, indicated with a V, the shorthand unit for volts, over it. Range. The HP 34401A is an auto-ranging meter, but you can force it out of this range if you want to make more work for yourself. We're keeping it in auto-range mode. Placement. Now that we're in DC voltmeter function, our leads are in the correct place, and we're in auto range, all we've got to do is place our voltmeter leads across our terminals of interest. In this case, we're again observing close to our expected value of 5 volts. If I swap the leads, we would expect to observe the same magnitude but of opposite polarity. Final note about these 3 different voltmeters is notice the small difference between readings we observe for the same voltage source. This voltage source is not a reference voltage source, meaning an official standard, nor are these voltmeters calibrated. We should expect to see variations in observations using different equipment. That being said, the voltmeters are in general agreement with each other, and I'd be reasonably confident this source is close enough to 5 volts. Alright, that about wraps it up for this quick look at voltmeters. See, I told you it'd be quick and easy. Don't think we're done with voltmeters though. I just wanted a brief summary of these guys before we looked at DC voltage sources and power supplies. I'll go into further details about voltmeters then, and additionally in later experimental verification videos. Remember to RTFM about your specific DMM used in voltmeter mode, and always, always, always use the function, leads, range, and placement checklist every time you employ it. In conclusion, this lecture took a brief look at the voltmeter function of the digital multimeter. We used the function, leads, range, and placement checklist for different voltmeters and discussed voltage polarity. Remember to review these concepts as often as you need to really drive it home. Imagine how well lab will go if you know what you're doing. Thank you very much for your attention and interest, and we'll see you again during the next lecture of our series. Remember to tell your lazy lab partner about this resource, and be sure to check out the Big Bad Tech channel for additional resources and updates.